Okay, so for this example, we want to find the slope of f of x is equal to the square root of 3 minus x at x equals 6. So this isn't saying to find the derivative in words, but it's saying to find the derivative. We're asked for the slope of a function. You guys should get to the point where you can easily interchange those words. Slope and derivative are the same thing. So when we say find the slope of a function, we mean find the derivative of the function at that point. So in other words, I can just replace this with the word derivative and see that this is actually a really similar question to the x squared plus 1 to find the derivative of the thing. So our first step here is going to be to find f of x plus h. So I'm just going to remind you guys real quick, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. And we're trying to plug this f of x into that function. So our first step is to find that f of x plus h, and if possible, simplify. So I remind you that in order to do that, I'm just using my f of x that I have right here. That's given. And I'm replacing x with x plus h in parentheses. Those parentheses, I'm going to rewrite them over in red because they're super important. Because notice what happens. Those parentheses tell me to distribute that minus sign. So this is 3 minus x minus h. It is not the square root of 3 minus x plus h. There are differences between those two things. It is not this one. We are subtracting that h, and that's actually super important. So this brings us to our second step. Our second step here is to plug in to that limit definition. So the limit as h approaches 0, f of x plus h we just found here, 3 minus x minus h, minus f of x, that's given in the beginning, root 3 minus x, all over h. Now we could plug in h equals 0 to see that this gives us 0 over 0, but because we're doing the limit definition, we know that it should. So our goal is going to be to cancel out a factor of h. In this case, we have square roots, so it makes sense that the technique that we're going to need to use is rationalization. So I'm going to multiply by the conjugate. And remember, when I multiply by the conjugate, it goes in the numerator and the denominator, which will result in the limit as h approaches 0, 3 minus x minus h minus 3 minus x over h times that conjugate. Okay, take a look at what I just wrote. Is everything correct? Did I forget something? If you're thinking that I forgot the parentheses, you are correct. Those parentheses are super important. I'm subtracting the whole root 3 minus x squared. So I'm subtracting all of 3 minus x. That minus sign gets distributed inside. A good way to double check here is, does a factor of h appear? If I don't distribute that minus sign, it won't. I'll have negative h minus x minus x, and I'll have negative h minus 2x. The x's won't cancel out. Let's write this over here. I'll have negative x, negative 2x minus h, and notice h is not a factor. So this is what happens if you forget to distribute the minus sign. So don't forget. So let's just immediately do it. The limit as h approaches 0, 3 minus x minus h minus 3 plus x. Look what happens when I don't forget. Those x's are going to cancel out over h times the conjugate minus x plus x is 0. 3 minus 3 is 0. And what I have left here is the limit as h approaches 0 of negative h over h times root 3 minus x minus h plus root 3 minus x. Yay, we now can see that h that we have in the numerator there, so we can cancel it out. Goodbye, goodbye. And what we have left is a 1, or rather a negative 1 in the numerator. Root 3 minus x minus h plus root 3 minus x. Now I plug in h equals 0 to get negative 1 over root 3 minus x minus 0 plus root 3 minus x. But guess what? Root 3 minus x minus 0 and root 3 minus x are the same thing. So f prime of x is equal to negative 1 over 2 root 3 minus x. And that is my derivative. Now be careful, we've talked about this before. The square root, I'm just going to put a, of a plus the square root of a, this is like terms. I have the same thing under both square roots. When I add them together, it doesn't cancel out the square root. It's like adding x plus x. I get 2 root a. So that's where that 2 showed up from. It's not the same as root a times root a. That does cancel out the square roots and give me an a. So be careful. Okay, so that's our derivative, our function that represents the slope. Final step, at x equals negative 6. That means plug in negative 6. So my 3 here, step 3 is f of negative 6 is equal to negative 1 over 2 times 3 minus negative 6. That's negative 1 over 2 root 9. Root 9 is 3. So that's negative 1 over 6. And this is the slope of the curve at x equals negative 6. Of curve at x equals negative 6. And if we want to draw a picture of this thing just to kind of see what it looks like, I'm not going to ask you guys to, but we can. This square root function starts being defined at 1, 2, 3. And so it was root 3 minus x, right? Yeah. So that's only defined for 3 minus x is greater than 0. So that is for x less than 3. So it kind of looks something like this. That kind of went off more than I wanted to. So it looks something like this. And here we're saying negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. If I keep this function going, if right here I draw a tangent line, and it's a little bit hard because that slope is really like practically flat, the slope of that line should be negative 1, 6. That's my tangent line. As you can see, I'm not the best artist. So our final answer was just that negative 1, 6. All right, in the next video, we'll see that we can actually sometimes find the equation of our tangent line.